Hey guys, welcome back to the shop for another week of Saturday Night Special. Tonight we're going to have quite a bit of machining footage for you. We go ahead and we get started on the K&T electric motor shaft right here. And we're going to go ahead and get this shaft completely roughed in. And then what we'll do is next week I'm going to set it back up in the lathe and we're going to finish it. So tonight, we'll be roughing it in, letting it cool, and then next week we'll finish it out. Probably finish all the turning and then putting the keyway in it, and then it's got a couple holes drilled through it as well. So I know a lot of guys have been excited about getting back on this project, and I'm excited about getting back on this project too, because I want to get this done, get the motor built, and then try to get this K&T mill back in running operation. So that's going to be the content for tonight for this video. Okay, I do have another machinery's handbook we're going to give away, and I also want to give a couple of honorable mentions as well. But let's go ahead and do our book giveaway. So this week what we have is a machinery's handbook that was donated to us by Mike Ray. Okay, and Mike Ray can be found under Practical Metal, YouTube, and he's also on a Practical Machinist as well. I love his sticker. I just love that. I love the old school welder look right there. Got the traditional pipe welder hood, so he sent me a couple stickers, and Mike, we will get your sticker over there on the cabinet. But Mike was very generous, and he actually sent several of these machinery's handbooks, so I have a few of them to give away from him. All right, so this is the 15th edition. All right, here we go. There's the 15th edition. By the way, Mike is from Columbiana, Alabama. And there was the previous owner. I'm not really sure how that last name, Thielen or Thielen, Dick Thielen, from New Britain, Connecticut, I believe is where that's from. Nice book. All right. So we now have a total of 1,226 entries into the Machinery's Handbook giveaway. And I used the random number generator. It popped up with a number of 132, so I went to the list. And the winner this week is Ron Enders from Rotterdam, New York. So congratulations, Ron. You got the 15th edition book right here. All right, so Ron answered my two questions. His favorite content is machining, welding, and hydraulic work. Cool. And then what he'd like to see more of, he just says that he's happy with everything that I show, and he loves the projects that I take on here in the shop, and he also loves the metallizing or the spray welding. So thank you very much for your answers there, Ron. I appreciate it, and I will get this book packaged up and coming your way real soon, okay? I wanted to give a couple of YouTube mentions out there to a couple of channels that I think are well deserving of some of you guys, some of your subscriptions and views. But first one you might already know, Fireball Tools. That's Jason over there at Fireball Tools. He's the one that invented these really cool welding squares right here. You got the Mega Square and then the Monster Square right here. These are the mini versions, by the way. But just showing you, an example of some of the stuff that he does. Jason, unfortunately, a few months ago, he was working on his YouTube channel. He was trying to switch it from, I think, from a private channel to like a business channel. And something really odd happened that particular day, and whenever he made the switch, YouTube actually deleted his channel completely. It just wiped it out, and he was not able to ever recover that previous channel. And I think he had between 7,000 and 8,000 subscribers that he just instantaneously lost. So Jason started a new channel, again, Fireball Tool, and he's been trying to slowly gain his subscribers back, and I really appreciate if you guys would go over there and check his channel out. Jason isn't, his YouTube channel isn't just trying to sell squares. That's not what he's trying to do with his channel. He sells squares, but that's not what his channel is about. He's actually just like us. He's a fabricator, and he likes to build things. He likes to do projects in his shop. So he's been doing more of those type of videos of actually projects, building things, and he's got a lot of ideas for things that he's going to build and share on his channel. And he just utilizes his tools in those videos. And of course, he'll use it whenever he needs to share something new that he's coming out with, But he's just a really cool guy, and I really appreciate getting to meet Jason and hanging out with him and both Atlanta and Texas, and I feel like that we've made a really good friendship there that's continuing to grow. And I actually plan to go and visit his shop sometime next year. He's up in Spokane, Washington, and he's got a nice shop that he's putting together there, and he's trying to bring more of his tooling productions in-house, doing a lot of it himself, but he's really building up a nice shop there where he can actually build some cool projects and put there on the channel. So be sure to go check him out, please, and give him a subscription. I know he would really appreciate it. For all you guys that lost that subscription because of YouTube, you know, go over there and hit subscribe again and check Jason out. So anyway, Jason, I know you watch. I really enjoyed hanging out with you over there in Texas, and you know, just getting to chat it up about shop talk and these tools and projects that we want to do and all that stuff. And also your brother Jameis, it was really cool meeting him, and I look forward to hanging out with you again at your shop. Okay. Another YouTube channel that I want to give an honorable mention to is the Museum of Our Industrial Heritage. Please go and check out their channel. And I've been in contact with these guys for quite some time. Scott Conti, he works there, and Scott also has a Instagram page, SPD Tool, and he works at Wells Tools that makes taps, the same Wells that you might know, that you might see an old Wells, you know, tap and die or something in your box. He works there. They're still in business making taps. But anyway, Museum of Our Industrial Heritage, they're located up in Greenfield, Massachusetts, where Greenfield Tap and Die was from. And they have some really cool videos on their channel, you know, some old movies of different things involving manufacturing and metalworking and cutting tools and things like that. They have some videos up of measuring tools like rules, micrometers, different types of cutting tools. They have a really cool movie on Greenfield Tap and Die, a movie that they had made back in the day. You know, this is, you know, decades back. And I know there's another video on the geometric die head, but they have a lot of really cool, interesting videos, and I think you guys might enjoy it. So please go over there, check out their channel, Museum of Our Industrial Heritage. I'll have a card up here, and I'll have a link down below that you can click on. And I really look forward to visiting with them. I'm hoping maybe next year I can take that New England vacation that I wanted to do and go by and visit the people at Sterrett and maybe get to tour the Sterrett plant, and then also go over there to Greenfield, Mass, and visit the museum there as well. Probably go north to Vermont. I think it's in Windsor where the Precision Museum is at. I want to go there as well. So that's sort of some of the things that I had wanted to do whenever I go up to Massachusetts. I don't know when that's going to be, but hopefully we're going to get to do that next year. So Scott, I really appreciate, you know, talking with you, and you guys continue to bring those really cool videos to your channel, and hopefully some of our viewers here on my channel will go over there and check you out, and you know, give you a subscription and give you a like, because those guys over at the museum are really looking for some views to know that, you know, the effort that they're putting forth into preserving these old movies is well appreciated. Okay, so go check them out. I've been excited to share this new tool acquisition. I just got it in this week. So what we have is a Reed 108 vise. This is the 8-inch jaws up here, and just showing you right there, we've got our 8-inch jaw, and this thing will open up to 12 inches plus. So you're probably wondering what the heck's going on with the paint job there. That is the beautiful artwork of my friend Andrew Alexander at Blacksmithing Tools on Instagram. So when I was there visiting his shop in Texas, in Dallas, I got to do a shop tour of his place, and which is going to be a video coming out. I haven't got to do it yet, but anyway, he's got a heck of a collection of these 8-inch Reed vices. I mean, he's got them just, I mean, you trip over them going into a shop. He's got so many of them. So I was really hammering on him hard about selling me one of these, because I've always liked these 8-inch vices, and they're just, you can't find them. You know, only guys like Andrew can find these things, it seems like. And I've been wanting to buy one for the shop as a project here. So anyway, he finally offered to sell me this one. He calls this one the belt buckle Reed, because of this, the way they did their logo right there. Traditionally, you know, Reed was casted in like raised lettering like right here. And I don't know when they did this. It's probably, I don't know, 50s, 60s if I had to guess. But anyway, he finally contacted me and said that he would sell me the belt buckle reed, and I offered to buy it. So that's what I did. And he was so mad at me for agreeing to buy this vise that he decided to paint it pink. So he went and bought some paint, sprayed it pink, just because he didn't like that I agreed to buy it. I guess he thought I was joking with him, but I really wanted one. So it's in really good shape, and I plan on making this a restoration project for the channel. And what I want to do is not only repaint it a proper color, not pink. I want to take it apart, clean it, give it a really good paint job, maybe do some detail work right here, and then I want to build a big, heavy, massive pedestal for this vise. I saw one at Andrew's shop that is an ultra rare pedestal that was casted for one of his other big 8-inch vices, and I'm going to kind of use that as sort of a reference on how I want to build a pedestal for this. I want it to be at least 1,000 pounds. I'm probably going to make it bigger than that, because the pedestal that Andrew has that I'm modeling off of, he said is 1,000 pounds. So I got to go bigger and I got to go heavier. So I've been kind of rounding up some materials to do that, and it's going to be a standalone pedestal that, you know, that'll sit on the floor somewhere. That'll have that sitting on it, and it'd be nice and heavy so you can't bump into it, knock it over, and it'll be a proper height. This is a little bit too high right here, so we want to bring the top of the vise down some, you know, around 35 or whatever inches. So anyway, just wanted to share that. I was excited about getting this. And Andrew, thank you very much for the paint job, dude. I was kind of messing around with the vise the other night whenever I got it up here on the table. So the jaws still seem to be in pretty good shape as far as the serrations go. But I took this pipe, just an old piece of pipe, and you can kind of see the vise marks along it. It looks like it's got nice parallel grip to it. I'll go ahead and we'll show it again. You can really crank down on a vise like this to hold something. You can give it some A-bomb torque. You can see it's holding pretty good. Got a lot of power in it. Got contact all the way down the jaw right there, so happy about that. But this is something that I look forward to doing here in the near future, is being able to give a proper restoration to this vise. We're going to go ahead and get started on this shaft. This is for the K&T, the Kearney and Trecker milling machine. This is out of the motor, and if you didn't catch this before, this one's bent down here on the end. Plus the bearing journals are wore out. Needs to be fixed. It's already been fixed once before. It's been welded up, so I decided to make a new shaft. So we've got a piece of 4140 ordered right here. I bought this from McMaster Car, and what we're going to do is go ahead and get it cut to the right length to start with. So we'll just measure the length here. We got some V blocks. We'll set it in. Put that magnet on that end there. I got my rule. Alright, so we're at 18 inches and 1/16. So we'll go over there and we'll cut at 18 and 3/16. That'll give us 1/8 of an inch on the end of it there to face the ends. So check that. Yep, 18 and 1/16. Alright, this is going to be a pretty straightforward job. So we'll take this piece of stock right there, cut it to the right length. We're going to face the ends, face and center drill the ends. And then what we'll do is we'll rough it. We're going to rough it first. Rough one end down. All right, flip it around. Rough the other end. Rough the center down. And then I'll let it cool and de-stress if it's going to move any. And then we set it back up and finish one end, finish the other end, that kind of stuff. So once we finish the turning, then we'll have one keyway that we got to mill here. And there's 2 holes drilled in there. I believe those are for the fans. So let's get started. All right, we got our 18 and 3/16 there. Put some of this corrosion inhibitor up here on this bar. Always seems to be tight. We're going to use the Victor lathe for this job and make use of this new 6-jaw chuck. I want to really see how it does for shaft work, you know, having the ability to dial this thing in. So we're going to give it a try. I usually use the 4 jaws, but we'll see how it goes this time around. We're going to start with the ends, getting it faced and center drilled on the end, and then we'll work off that center there. We'll see what kind of run out we're getting here. About 1 thousandths to 1 thousandths and a half. Okay, not bad. Alright, we got our one side face there. I'm going to come back over here and get a measurement on it. So I know this isn't faced yet, but we are showing 18 1/8, so we want a 1/16 off of it. What we'll do, I'm going to go back to the lathe and I'm going to face half of that. So we're going to take like 30 thousandths off that face, come back and measure it again, and I'll get a more precise measurement on how much needs to come off of that face. That overall length right there isn't super critical. You know, if you get that within, let's say, 10-15 thousandths overall length, you're going to be fine. What you want to maintain here, not only your journal sizes here, but you know, if you maintain this distance between here and here, you'll be good to go. If you're sticking out 5 or 10 thousandths on the end there on a shaft like this, it's not going to hurt anything. You just want your center distances to be right. All right, let's go back to our V blocks and measure it out again. All right, let's get a measurement on this. We're going to do it like we're going to scale it out. Now, I was going to say that I would normally measure this with a vernier caliper. And I have some 24-inch vernier calipers, but I keep them at work, use them down there quite a bit, more than I do here. And so I just don't have them here. And I do have some 36-inch vernier calipers I could use, but I don't feel like lugging those things out for a short piece like this. So I'm just going to use my scales. The scale or rule is going to get you close enough. All right, that's going to get you where you want to go. So we should have approximately a 32nd to come off based off that last cut. I took a 30 thousandths, but we'll figure it out here. So let's see. So I've actually got a little more than a 32nd. So what I need to do is flip it over onto the 64th side. Remember, we want to finish this at 18, 18 and 16th. I know all you metric guys are just going nuts right now. I love it. All right, so what we have though is 18 and 7/64 of an inch as our length right there. Let me double check that. Come on, get down there on my magnet. Yeah, 18 and 7/64. So that is going to be, I believe it's 0.109. Let me check my chart. 7/64. Yeah, 0.109. So 0.109 should be around 47 thousandths minus 0.062. That's a 16th there. Yeah, so 47 thousandths. That's going to be our cut length there on the end, and that'll put us at 18 and 1/16 of an inch, or 18.062. So what we're going to do is we're going to touch this thing lightly, like that. I'm going to take 45. Thought I'd show you the run out on this end since we did the other. Looks to be the same, about 1.5 thousandths total. What I'm going to do on this end is just skin it to make the OD true with that center cut. So that I flip it around and chuck it on that end there, and it's true. And we're going to try this carbide insert here. This is a Seco TP3500, and I'm going to try it for a roughing cut and see what kind of chip we can get. If I can't get good chip control with that, we'll swap it out to another one and give it a try. Alright, come down here and then we're going to retighten our chuck. Okay, we're going to go ahead and start roughing this shaft in, and that's what I'm going to do. We're going to rough in both sides, rough in the center, and then let the shaft cool and then set it back up. All right, so our first length here from the end, I just set a 0. That's going to be 64 millimeters back to our shoulder, and then our diameter is going to be 35 millimeters, but it's going to be sized accordingly like it's supposed to be for our chart. So we're also going to be using my Noga. This is the Noga Mini Cool. Get a lot of questions about this. I use this at work because on the pacemaker I do not have flood coolant. The only flood coolant lay that I have is my Monarch over there, so that's why you see it over there sometimes. But this works really well, and I'll show you how it works. First thing I want to do is go ahead and make a mark. I'm going to use the blue Sharpie right here and just kind of paint about where that tool's at. It's just another little witness mark. Alright, so that just kind of gives me a reference as I'm coming up to that area right there. So about the Noga Cool, I've got it plugged into my airline. I've got a bucket behind you with the Cool Mist Cool Mist Formula 77 mixed with water. Alright, and then you see I've got it just kind of blowing right on that tip. So it serves two purposes. It's keeping this tool and this carbide cool, just like flood coolant will, and it also helps keep the temperature of the shaft down as well. So you can regulate the amount of oxygen you want going through it, the amount of air I mean. You can also regulate it here to how much coolant you want coming out of that. You can really flood it, or you can back it down. So I'll try to keep it somewhere around there. It also helps keep chips blowed away from the tool there as well. So let's go ahead and see if this lathe is going to handle some cutting. It's been a while since I've done a shaft over here. I'm going to touch off, and we're going to try like some 1/8 cuts. Nothing heavy duty. Okay, that's looking pretty good right there. A little bit more coolant. That insert's looking pretty good, actually. You can see how well that Noga Cool works, you know, versus flood coolant, because I don't have flood coolant over here, but it gets the job done. I use this at work doing those big heavy 4140 shafts, and when I'm done making a bunch of heavy cuts, I mean, I can grab this with my hand. It keeps it nice and cool. So we're starting out at 2 inches, and we'll be coming down to about 1 3/8. That's the same thing as 35 millimeters. So we're just going to take some 1/8 cuts. All right, so I'm getting down to my final roughing passes now. I'm going to finish this thing at about a 1/16 over. So I'm shooting for 1 inch 437, 1 7/16. So that's about 60 thou of what we need to take off there. 62, I mean. So I don't know how this is going to do once I back off on the cut. We're going to take 30 thousandths. There's 30. Let's see if it breaks the chip. No, see, it don't want to break a chip very well. But that'll work there. I'm just trying to eliminate having to change the insert. Here's the mic I'm going to use. This is a Brown & Sharp 1-2. And earlier I checked it against a 1-inch gauge block and also a 1-inch pin gauge as well. And it's reading right on. So let's see what we're micing right there. All right, so that's 478. So that's 41 thousandths or so. I'm just going to take 40 thousandths, and that's going to be our finished pass there. 40. Look at that. You know, I can't believe that it's going to do that to me on the finish. Cut. Man. Slow it down. It's okay. This is it's a rough surface, so we've got to finish that in. Let's go ahead and see where I hit it at. All right. 434. I'm going to see if I can clean that chatter up. All I did was touch off and just dial in like 2 or 3. All right. That makes me feel a little bit better right there. Okay, so let's take this tool out, and we're going to put our chamfering tool, my MCHNN, and we're going to break those edges there. Just want to break them. before I tighten that chuck up all the way, I want to bring my center back up to it. And I always try to keep my tailstock stick out as short as possible. So I'm going to reposition this tool up here to where I get a little bit of room left. And then just bring my tailstock up. All right, clean the center off. All right, now we'll go ahead and snug up our 6 jaw here. Let's see what kind of run out we're showing right here behind our turn journal. .1,000. So it's the same run out that we had showed earlier, measuring on the OD in a random place after chucking it. So it's looking like we're going to be pretty good to go for roughing. So yeah, let's go ahead and roll with it. There's our old shaft, and I've jotted down the measurements that I want to make this to on there, and that's just for a quick reference. I don't have to continue to measure it. I've added just a little bit on this shoulder right here because it looks like it's done some rubbing. I'm not really sure, but it looks like it's got maybe a little bit of wear right there on the shoulder. So I've added just a little bit, about 15 thousandths to that shoulder. So we're going to make it 8 inches 93. That's really close. It's between 105 and 106 millimeters, I believe. And then so that length right there from here to this shoulder is going to put us at 7 3/8. All right. So there's our diameter that we're going to be going to again. So it's going to be the same as the other side. It's 35 millimeters, but we'll have it sized properly right here for our bearing journal, and then we'll have it slightly under from this point on. It fits the you got the pulley that goes on there and a fan that goes there as well. It's going to be really sweet once I get that new all DRO hooked up on this lathe, and I don't have to do it like this all the time. So I'm using my Starrett hook rule here, hooking the end, and then we're going to line up the tool bit right on the 7 3/8 line right there. And that's going to give me a little bit of material to work with in between the shoulder links. So I'll actually use my calipers and make sure that these are faced in like I want to, and if there's a little bit of extra shaft sticking out the shaft end is where you're going to want it right there. So let me just make sure that I have this where I want it, and then we'll go to our cut. All right, it's looking good right about there. 7 3/8. I usually double check. A lot of times once I get it set where I want it, I come back in there and just kind of refresh and make sure that I'm on 7 starting from one side, and then 3/8, so it'll be the third line there. So let's go ahead and mark it with our Sharpie. Let's go ahead and set our indicator right here. I'm going to set a 0. So that'll be our stop. Just come up and touch it. All right. Let's see if this thing's going to handle 600 RPM. We got our cut set. And sometimes it does that right on the start. So on this other end, you remember how we had our chatter problems because I had backed off on the cut and was only doing 30. So what I want to do now is I'm going to split this into 2 finishing passes. We're at 1 3/4 on our sizing. So that would be, the 2 roughing cuts at an 1/8 of an inch depth. plus the 60 thousandths. So we're at 1 inch 750 right there. I want to check this in and see what kind of taper I'm getting. And it looks like it's machining right on, 1 3/4 inches. All right, so that's going to leave us 5/16, 312. Let me just do the math real quick. So 0.750 minus 0.437. Okay, yeah, so 5/16 is left. Divided by 2 cuts, so we're going to take 156. Let's see if it'll handle it, okay? All right, you can see it's starting to get a little bit warm now. If that mist was not spraying on this thing, it would be very hot at this point. Now I want to go ahead and mic it and see if I'm correct on my sizing, but we're just going to finish it out. All right, so that's 75, 85, 96, I'm sorry, 592. Yep. And we got 592. So 0.592 minus 0.437 is 155 thousandths. So we're right where we want to be. So we're going to take one more roughing cut. Let's say 150, 155. So there's 100, there's 50, and then there's 5. Okay. We're at 439, so I was off by 2 thousandths. 1 inch 439. All right, good. Let's go ahead and rough our center. So I'm up against the jaws here, so I've got to move it back a little bit. I'm going to go ahead and loosen the tailstock and just push it out that way. What I want to do is make sure I leave myself enough room here so I can get my chamfering tool in there. It looks like that'll work right there. All right, so let me start with my marked pinion. Snug it there. Now I'm going to re-tighten up the tailstock here. We'll go back to the chuck, make sure it's tight. Let's see what the indicator is reading right up here on this journal now that I moved it, taken it out. 1 thousandths. It looks like it's repeating well, this chuck is, so we may be able to finish everything right here in this chuck. I'm going to finish this journal here at 1 inch 820. And that should give me a little over 60 thousandths to finish it down. So that's 180 thousandths I want to take off. So I'm going to do 90 thousandths cuts, and let's see how that goes. Less depth of cut there. That's why it's trying to string out a little bit more. 910. That one's 910 right there. So that's going to leave us with what, 90 thousandths. Let's do the math real quick. 0.910 minus 0.820, 90. I just like verifying that instead of doing it all in my head all the time. So let's do another 90 thousandths. See if I hit my 1" 820. One inch 820. We did good there. 1" 820. All right, so I just need to deburr that. By the way, you see this right here, the nozzle, see how it's dripping? So I've got the bucket of coolant sitting on top of the tailstock. So this will siphon out if you don't close this. I mean, you just disconnect it from there, but it's always good practice to go ahead and shut that nozzle all the way off whenever you're done using it there. Well, what we're going to do, we're going to end this here. I'm going to take this out of the lathe. I'm going to go put it on the table. I'm just going to let it cool down. And then so when we come back, we're going to start our finishing process, okay? We'll see you then.